So now we're going to practice a couple of momentum problems. What is the momentum of an 80 kilogram person running at 10 meters per second? That one's straightforward. Number 2, what is the momentum of a 1,121 kilogram car that travels a distance of 75 meters in 32 seconds? So that's a mass. Distance and time, meaning we're going to have to use velocity. We're going to have to calculate that before we can do it. 2 steps. Number 3, what velocity does a 100 kilogram car have if it has the same momentum as a 10,000 kilogram truck traveling at 10 meters a second? So this one also, 2 different things, truck, car. You only have enough data for the truck, so you have to figure out its momentum first, but it's the same as the car, and then we'll solve it for the car. Number 4, if 2 cars have the same momentum, but car A is traveling at 10 meters per second and car B is traveling at 100 meters per second, what is the mass of car B if the mass of car A is 500 kilograms? Again, it's a 2-step problem, much like number 3. Before I work these, pause the video here and try to work them out yourself. And these are our answers. You can go ahead and see if you got the right answer or not. If not, it's okay. The next thing I'm going to do is work them out one by one. So the first thing I want to do in problem 1 is identify my mass and then identify my velocity in my problem. So 80 kilograms for mass, 10 meters per second for velocity. Then I can just plug it in my equation. So 80 kilograms for mass multiplied by 10 meters per second for velocity. And it's going to give me a momentum of 800. 800 what? It's kilogram meters per second. That is your unit for momentum. Box it in. Let's double check that I was correct. Yep, 800 kilogram meters per second for our momentum for number 1. Let's look at number 2. So like I said, in this one, we're going to have to identify different things. First, our mass for our car. Then we need to look into what makes velocity. So that's distance, 75 meters, and 3.2 seconds is our time. Now that we have those, we can start to plug those into what we know. So with the velocity, we have all of our variables. We're going to plug in 75 meters divided by 3.2 seconds. And that's going to get us a velocity of 23.4 meters per second. Now I'm just going to kind of squiggle line that because it's not our final answer. It's just the velocity we had to solve for our momentum problem. So now we can start to work our momentum problem by plugging in our variables. First, we have 1,121 kilograms. And we're going to multiply that by the velocity that we just found, 23.4 meters per second. And this is going to give us a momentum of 26,231.4 kilogram meters per second. And I'm going to box that one in because that is my answer. So if you look, this number is slightly different than what we got. We got 26,231.4, not 73. That's just a rounding error. I rounded when I got my velocity, and so it changed the value of this. That's not a big thing. Most of the time, there's something to account for that in the margin of errors. So this is still a correct answer. So much like the last problem, in this problem it's 2 steps, but this time we're still going to be using the momentum formula and not the velocity formula. But it is asking for the velocity of a car, so that means we're going to have to rearrange it. So I have my triangle here, but then I also have 2 different things that I'm going to be finding it for, my truck and my car. Now in science, we like to use subscripts to designate which these are. So I'm going to write all of my variables for the momentum formula for my truck and my car, but I'm going to add a subscript. So here's my momentum, it's a P, but I'm going to add a subscript of a T so that I know it's for the truck. My velocity for the truck has a subscript T, and my mass for the truck has a subscript T. My car, on the other hand, I'm going to make a subscript for c, so I can identify that it is the car's momentum for a c, and the car's velocity, and then also the car's mass. Now that subscript identifies what we have information for, and we can go back and find this in there. We know the car has 100 kilogram, so that's a mass. But that's all we really know, other than it does give us a classifying statement. And it basically says the momentum is the same for both of them. So I can say for a fact that the momentum of the truck is equal to the momentum of the car, which is going to be good because we can calculate the momentum of the truck. So right now, let's see what we have for the truck. For the truck, we have a mass of 10,000 kilograms and a velocity of 10 meters per second. With that, we can go ahead and plug that into the momentum formula, and we'll be able to get the momentum of the truck, because this is all T, remember? Momentum of the truck. So you even do it in the formula, and then we're going to get that that's 10,000 kilograms multiplied by 10 meters per second, which is just going to give us 100,000 kilogram meters per second. Now, I kind of boxed that in, but I need a squiggly line because it's not my final answer. I can now plug that into the momentum of my car. We know my car is 100,000 kilogram meters per second momentum. And so I only need to solve for the velocity. Let me clean this up before we do that. So now I cleaned it up, and the first thing I'm going to need to do is I know I need to find my velocity. So I'm going to cover up that V, and that's going to tell me that my new formula is going to be velocity equals, and then I see that I have momentum divided by mass, and this is all of the car. So now I can plug in that because I have that for both of them. 100,000 kilogram meters per second divided by 100 kilograms. And if you put that in your calculator, you're going to get that we have a speed of 1,000 meters per second. And so that's going to be my answer. That's a 1. And here you can see that 1,000 meters per second is exactly what you needed with number 3. So now we just do number 5. So this problem is a lot like our last problem. We have two different things, car A and car B, but we see that they have the same momentum. So we need an equivalent statement, being the momentum of car A is equal to the momentum of car B. Now that we have that, let's look at what the problem gives us for each of the car's variables. Car A has a velocity of 10 meters per second. Car B has a velocity of 100 meters per second. But then we find out that car A has a mass of 500 kilograms, and that's all we can fill out. But this does give us everything we need to do the momentum of car A. So we write out that formula. Notice my subscripts, momentum A, mass A, velocity A, and then I plug in my values. 500 kilograms times 10 meters per second is going to equal 5,000 kilogram meters per second. Now that I have the value of the momentum of car A, I can write that in right up here for my car A momentum. But because of our equivalency statement, we know that whatever it was for the momentum of A has to be what it was for B, meaning we can also write that value in for the momentum of car B, meaning we now have two variables for it and can solve for the last one. We just need to clean it up a bit. Now I can solve for that mass of car B. I'm going to use my triangle to get a new formula. So I covered up the M for mass of car B. What that means is I'm now saying mass equals, so mass of B equals the momentum of B divided by the velocity of B. What I now have is a formula for B solved for the mass that I can plug the variables that I know in there. So I put 5,000 kilogram meters per second divided by 100 meters per second, my velocity, gives me 50 kilograms. And I'm going to go ahead and put this up here, and 50 kilograms is the mass of car B, so that's what I'm going to box in as my answer. And there we have it. Here we can see, yes, our last one was 50 kilograms. We got it right again. And that's how you do all 4 of these.